My name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 240. Please turn to it. Page number 240, and today is our lesson number 340. These two problems that you see there on that page, page number 240, problem number 2.9.1 and 2.9.2 are the exact two problems that appeared in the first edition of the revised GRE. If you're in, and we have already solved every single math problem from this book. If you're interested in watching the original solutions in its original version, you will find the original solutions on day number 128 and 129. Here we're going to put the two problems together and we're going to do them in a slightly different version. So here's what the problem says. The problem says, where do the line f of x equals to negative half x plus 1 is a linear equation, obviously, therefore it's a line, is a linear equation. Where do the line and the parabola, and the equation the parabola is given to us, where do the line negative half x plus 1 and the parabola y equals to x squared intersect? That's what it is. Let's find out, shall we? Let's find out where they intersect. Before we actually figure out the exact coordinate of it, let's first look at it on the graph to get some rough idea as to what we're dealing with. With the parabola that is given to us, it's a quite straightforward parabola. It is sitting right at the origin, nothing to it. It's a very straightforward parabola. If you look at the line, we are told that fx equals to negative 1/2 x plus 1, which of course is the value of y. So first thing we notice is that the slope is negative. It has a negative slope. It has a negative slope. Second thing we notice is that when x is equal to 0, the y is going to be negative 1/2 times 0 plus 1, which is just 1. When x is equal to 0, the handwriting is getting very sloppy. When x is equal to 0, 0 times anything is 0, and then you get 1, which means the y-intercept, x is equal to 0 right here. So it goes through here, 0 and 1. That's all we know so far. We know that it goes through this point because we know the intercept. We also know that it's a negatively sloped line. If it's negatively sloped line, it's like this somewhere. We want to find out the coordinates of this point and that point. And that's all there is. That's all there is. Nothing to it. Find out the coordinate of this point and coordinates of that point. Shall we? Let's do it. So the place where they intersect, of course, the coordinates of this point has to satisfy the line as well as the parabola, which is why we say that they intersect there, which means the value of the y coordinate over there is the same. And so is the value of the x coordinate, a little bit of effect. So the line here is negative half x plus 1, and that has to be same as the y coordinate of the other guy, the parabola. We equate the two and we just solve for x. Let's see what we can do here. We don't need this part here. Let's multiply the entire equation. I'm not going to explain every single step, as I told you. If you need help in a little bit of a detailed manner, and if you get lost somewhere, always a good idea to watch the original solutions, which are done at a slower pace. Let's multiply the entire equation by 2, and if we do that, multiply this equation by this side of the equation by 2, multiply this side of the equation by 2, and when we do that, this 2 is going to cancel out with that 2. We're going to get negative half, and then we get. You see, the more I try to explain, the longer it takes. It's too childish. Let's just do it. Let's just do. Multiply the entire equation by 2, and what we find is that this negative 2, this is going to go away. This 2 is going to go away. We get negative x plus 2 equals negative 2x equals 2x squared. We have to write this in the standard form. Let's bring everything on that side. So we find 2x squared plus 2x minus 2, 0. It should not be 2x, it's a negative x. It should be x. This is it. It's a quite straightforward quadratic equation. And watch what happens. And now, what we are asking ourselves is, we get a 2 here, we get a negative 2 here, which means 2 times negative 2 is 4. We are looking for two numbers such that their product equals a negative 4, because 2 times negative 2 is negative 4, and their sum equals a positive 1. And try as you will find that no such integers exist. No such integers exist. There are no integers, okay, listen carefully, there are no integers which when multiplied together will give us a product of negative 4. We're looking for some two numbers. When we multiply them together, we want a negative 4. When we add them together, we get a positive 1. And if you're lost at this point, if you do not know what I'm talking about, if you have any doubt at all as to what the hell is going on here, that's an indication, that's a clear indication that you have not been watching all the videos in the proper sequence. It is the course. This is not just problems here and there. These topics, they build on each other. If you are lost here, which means you need help big time in the concept of factorization, which is why I have not erased this thing from 2 days ago. These are the problem on factorization, which is what we're doing here. We're trying to find the factors. These problems will give you the practice that you need and to be able to understand what I'm talking about right now. No such factors exist. No such integers exist. That's a clear indication to us that our only salvation is to use quadratic formula. I don't like using quadratic formula. I avoid it if I can, because it's just not fun to use the quadratic formula. It's much easier to actually find the factors. But no such factors exist. There are no two numbers. There are no two whole numbers, that is, integers, which when multiplied by together is going to give us a product of negative 4. And when added up together is going to give us a sum. It's going to give us a sum of positive 1. No such numbers exist. Quadratic formula is our only salvation. Let's do it up here. And quadratic formula goes something like this: x equals to negative b plus or minus b squared minus 4ac over 2a. This is their way of saying, the people who are going to give you the exam, this is their way of saying that they expect you to know quadratic formula by heart, because there are going to be some problems. You are going to come across a couple of problems in the exams where the only way to solve the problem, the only way to find the value of the unknown is by use of the quadratic formula. Factorization will not get you anywhere. So you must know your quadratic formula by heart. Now in our case here, in this equation, our A is positive 2, our B is positive 1, and our C is negative 2. And those are the values that are going to go here. A represents the coefficient of x squared, B represents the coefficient of x, and C represents the constant. Let's put them in here. Minus b is positive 1, so minus b is going to be minus 1, plus or minus b squared, b is 1, so it's going to be 1 squared minus 4 times a, which is 2, times 4 times a times c, which is negative 2, over 2a, 2 times a, which is 2 times 2, a is 2. That's it. Now we have to simplify it. And of course, you have to have the practice so that you can do this fast enough in the exam. You cannot take forever and ever as we're taking here. 4 times 2 is 8, 8 times 2 is 16, so it's negative 16. This whole thing is going to give us a negative 16, but then we have a negative in front of it, so it becomes positive 16. It becomes 1 plus 16 over 4. 1 plus 16 over 4, of course, is 17. Now this is where you have to make a call, okay? Listen carefully. This is where you have to make the call in the real exam as to how much time you want to invest in it. Very, very, very rarely, once in a blue moon, you will actually need the calculator in the exam. Even though the calculator is there on the screen, you mustn't reach for it all the time. It is there, it's a tool, you use it only when it is absolutely necessary. In most cases, in vast majority of the cases, you can approximate and you can get away with it because it's a multiple choice questions. You just have to find the answer that comes closest to what you found, which is exactly what we're going to do here. We're going to approximate it, that's all. Don't worry about it. So we're going to pretend, even though this says 17, we're going to pretend that it is 16. So that means this is approximately equal to -1 plus or minus. Had it been 16, this would have been 4. Square root of 16 is 4 over 4, which means x is equal to -1 plus 4 over 4, or x is equal to -1 minus 4 over 4. -1 plus 4 over 4, that's 3 over 4, which means x is approximately 0.75. This 0.75. This should say approximately. Similarly here, it's going to be -5 over 4. It should not say equal, it should say approximately equal, which is going to be approximately 1.25. And that, in most cases, it should be sufficient to be able to locate the right answer. Now those are only the x coordinates of the 2 points, the 2 points of intersection. Now we have to find the corresponding y coordinates. To find the y coordinates, we have a choice. We can either substitute this x coordinates into the linear equations because they intersect. Both x coordinate and y coordinate are the same for both of the graph there because they share that point. So we can substitute this x coordinate value of the x coordinate in either the linear equation, the equation of the line, or the equation of the parabola. I'm going to use parabola because it's simpler. Let's do it up here. So if x happens to be 3/4, then y we know is x squared, which is going to be 3/4 squared, which is going to be y. It should not say equal to, it should say y is approximately equal to, which is 9 over 16, which is equal to 1 and 1/16. 1 and 1/16. Or if x happens to be -5/4, then y is going to be approximately -5/4 squared, which is 25 over 16, which tells us that y is going to be 1 and 9/16. Why does it say 1 and 9/16? It should not say 1 and 9/16. That's not what I meant to say. I meant to say 8/16 plus 1/16. 9/16 is same as x 8/16 over 1/16. Why are we writing it like this? Because 8/16 is half. 8/16 is half. We just have to figure out what 1/16 is. And these are the kind of things you have to know. You have to know by heart. You have to have this thing at your fingertips. Or if you don't, you have to be able to do it very quickly during the exam. You have to train yourself for that. So now I'm going to show you how to figure out 1/16 in a hurry. How do we figure out 1/16 in a hurry? Well, that's very simple. We know 1/4 is 0.25. Therefore 1/8 should be half of 25. Half of 25 is 12.5. And therefore 1/16 is going to be half of that. Half of 12 is 6. So it's 6.5. 6 point. There you go. In other words, 1/4 is 25%. That's what we're saying. 1/4 is 25%. 1/8 is 12.5%, and 1/16 is 6.25%. So that's what that is. So what we get here is that y is approximately 0.5 plus 0.0625, which gives us 0.5625. it's a good idea while you're practicing these questions on your own in the book to not reach for the calculator. If you do not reach for the calculator, it makes you use your brain more. Now in the real exam, if you don't want to take this much time and if you simply want to click on the calculator and figure out what the square root of 17 is, it's perfectly okay. That's what it's there for. But train yourself. The more you work with the numbers, the more conversant you will become. More conversant you will be. The more you use the numbers, the more conversant you will be. And what it means to be conversant? Should we learn it? Shall we? I'm pretty sure we covered this word in our vocabulary lessons. We are digressing here big time. Conversant. I hope we did it. I'm looking for my words here. Oh, there you go. Day number 3, as a matter of fact. Just type in vocabulary words for GRE. Type in vocabulary words for GRE day 3, and you will see a video, vocabulary video, in which you will learn the word conversant, which simply means to be skilled at something, to be good at something. If you want to be skilled, if you want to be good at something, if you want to be familiarized with, if you want to familiarize yourself with something, if you want to be comfortable with something, you have to practice. That's what this is. Let's continue. Enough of the talk. And this is just one more than that. This was 9/16, this is 1 and 9/16. And this y is going to be approximately 1.5625. And that's all. That's all. Which is pretty close to what they show you in the book. What I'm going to do now is, just for learning purposes, for no other purposes, just to make you see how to manipulate numbers and how to be nimble and how to be agile with the numbers, so that we don't freeze there like a deer caught in a headlight. Let's pick up from here. What we had was, let's leave it alone, let's leave this part alone. What we had was x was equal to, where did it go? -1 plus or minus the square root of 17 over 4. If you had to approximate 17, the square root of 17 that is, can you approximate very quickly what the square root of 17 might be? That's my question. Think about it for a second if you have to. Can you give me an approximate answer, something that comes very close to 17? Well, we know square root of 16 is 4. Listen very carefully. Square root of 16 is 4. 17 is just a little over it. My first instinct would be to try out 41. Listen to what I mean by 41. Watch what happens. 41 times 41. And 41 times 41 should not take forever. It should take no more than 2 or 3 seconds to figure out what 41 times 41 is. 41 times 1 is 41, so that's 1, carry 4. And what is 41 times 4? 41 times 4, I know 40 times 4 is 160. Do you agree? 40 times 4 is 160. Therefore, 41 times 4 should be 164. 164 plus a 4, 168. 168, voila. What does it tell you? It tells us that 4.1 times 4.1 is 16.1, which means the square root of 16.1 is equal to 4.1. And therefore we can claim that the square root of 17 is approximately 4.1. Square root of 17 is approximately 4.1. That's a pretty damn good estimate, because we are very close to 17. And we could have picked up our story from there. We could have just as well picked up our story from there. Let's do that. Let's do it up here, and I'm going to show you now how to pick up our story from here. So now what we get is -1 plus 4.1 and -1 and a minus 4.1. X equals -1 plus 4.1 over 4, which is going to give us 3.1 over 4. Now watch what happens. 31, listen very carefully, okay? 31 over 4 is 7. 7 times 7 4s are 28, and it's going to have a remainder of 3. You should be able to see immediately that 31 over 4 is simply 7 3/4. 7 3/4. But we are not dividing 31 by 4, we are dividing 3.1 by 4. So you just stick a decimal in there, and that decimal appears here. Let's solve. 3.1 is going to be 0.737 and 3/4. Now I bet you've never seen a number written like this, and this is not something we want to show it to somebody. This is for our own use. We're not going to leave it like this, it'll be insane. What this is actually is, it is 0.7 and then 3/4, which is 7.5. So x is approximately, actually it wouldn't be approximate, it will be exact. No, it is approximately, because square root of 17 is not 4.1. Square root of 17 is approximately 4.1. So we do need approximately here. X is approximately equal to this amount, which we just found out to be 0.775. There you go. 0.775. And what does the book say? 0.78, you see? Similarly, we could have done the other part. The other part tells us it is, I need the room. Where can we do it? Let's do it here. So the second one is x is approximately equal to -1 minus a 4.1 over 4. Again, the approximate part comes from the fact that the square root of 17 is not 4.1, square root of 17 is approximately 4.1. So now we get 5.1, -5.1 over 4. Let's do it up here. So we're dividing 51 by 4. Watch what happens. How many 4s in a 5? 5 has 1 4. The remaining 3 goes and joins 33. The remaining 1 goes, remaining 1 goes and joins 1, becomes 11 rather. How many 4s in 11? 11 has 2 4s. 11 has 2 4s. The remaining one, that's right. Now we have a remaining 3. The 3 is going to go and joins the 0, becomes 30. How many 4s in a 30? 30 has 7 8s are 7 4s are 28. The remaining 2 goes and joins this 0, becomes 20, and 20 has 5. So 5.1 is 1.275. 1.275. There you go. But like I said before, these are not the sort of insanity. These are not the sort of insanities we will do during the exam, and the exam time is very precious. But during the practice, when you're solving the problem on your own, and the whole purpose of solving the problem on your own is the learning purpose behind it. And for learning purposes, it is not a bad idea to do these kind of exercises, so that you begin to think outside the box, so that you don't reach for the bloody calculator every 3 seconds. I'm done with my sermon. I'm in.